Most of my videos just come with one disclaimer, but this one comes with two. Actually, most of them come with none, but this one's still coming with two. First, no routing protocols were harmed in the making of this video because none of them are in use. And secondly, I know you know what we're about to look at. I just want to go over it anyway, and I'm going to throw in one or two extra little tidbits to make it worth your while. But in this particular case, or in this walkthrough, when 192.168.1.1 wants to send packets to 10.1.1.5, it knows darn well that it's not on the same subnet as 10.1.1.5. So what a host is going to do is send the packets to our default gateway. We know that's a very important part of our DHCP config and a very important part of a manual config if that's what you're doing at the host level. Because what we're doing then is saying, hey, the host is saying, here are the packets for this guy. I don't have any idea where this guy is. Please send them to this guy. And the default gateway is going to take care of that situation, especially in this case, because when a router receives a packet, there are three possibilities regarding the packet's destination. It's either on a directly connected network, it's either on a non-directly connected network the router has an entry for in its IP routing table, or finally a non-directly connected network the router has no entry for in its IP routing table. And we're going to take a look at each possibility, and actually we're looking at one possibility there, but let's look at it right here. Nothing too complicated here, right? I mean, routing can't get any easier, and I'm sure it will never get any more complicated. The router looks in its IP routing table, sees 10.1.1.0/24 is directly connected, sends the packets out that interface, bada bing, bada boom, you got routed packets. Nothing to it. So let's just make things a little more complicated and add a router. And the problem here is that when the host default gateway gets these packets, that particular router only knows of the directly connected networks because we have no routing protocols configured. So the receiving router here knows about 192.168.1.0 and 10.1.1.0 both /24 networks. So a routing table lookup for 30.1.1.1 is going to fail. Now we could put a static route on router 1, the receiving router there, or get a dynamic routing protocol up and running, or we're SOOL sure out of luck. Now a static route that would get the job done would be 30.1.1.0, then 255.255.255.0, 10.1.1.1.02, that being the next hop address. Just a quick reminder with that IP route command, because it may have been a while since you got your NA, and static routes aren't something we all write every single day. And let me go ahead and bring up the live equipment here. That's a little better, especially if it's on target. Let me shrink that up just a tad, because it's going to go to the bottom, and there it goes. So looking at that command, IP route, it's going to be the destination prefix first. I'm not even going to put the one that was on the board. And then the destination prefix mask, we know that part. Don't use a paren there though. And then you're either putting the local exit interface or the next hop IP address. If you actually try to put the local interface, the exit interface's IP address on there, you'll get a little message that says we can't do that because it's this router. We know that multiple choice questions on your exam may not be as kind, so I wanted to remind you of the syntax of the IP route command. Now also in this case, if 30.1.1.1 is sending packets to 192.168.1.1, we would need another static route, because the host at 30.1.1.1 is going to send those packets to its default gateway at 30.1.1.2, and that router is going to say, what do you want from my life? I don't know where the 192.168.0.0 network is, or 192.168.1.0/24. So you just got to watch that kind of thing. It's not, you don't run into many production environments where you're just looking at static routes, but you might look at some exam questions, which is really why I wanted to show you that IP route command. Also, brush up on your admin distances. You know that that's used as a tiebreaker when a router has two routes to choose from or more, and it's the exact same route, exact same prefix, then the lowest administrative distance will be preferred. You're going to be seeing quite a few of the ADs 90, 170, 110, and a little 120 thrown into one section just for good measure. But just be familiar with your admin distances also for static routes and connected interfaces. And that is it for this particular review video. 4.5 minutes, not bad at all. Well worth your time. It is time to move on to the next section, start diving into the meat of the course, and I will see you there.